Alright, here is the kind of introduction and actually progress video for the rendering um, issue. Right now, basically, I'm going to be using OpenGL 4, and the current situation right now, I'm trying to wrap up certain aspects of OpenGL 4 for a specific purpose. Um, and I'll describe. The the API is called, I guess, GL wrapper for short. It basically wraps up all the kind of modern OpenGL components that I will be using throughout the project. The first four, I have completed several of them before I started documenting these videos. Um, I should have started documenting it earlier. The first four cover kind of the shader slash program pipeline. Um, every one of these components, shader, uniform, vertex array, and program, is basically for how shaders and that sort of stuff is kind of arranged. Um, these two right down here are basically vertex buffer and index buffer. Vertex buffer handles is basically a memory location on the RAM. It's kind of a given point that contains vertices, which includes vertices, text chords, normals, tangents, bitangents, just anything that's data that's in an array form. That's what a vertex buffer does. The contrast, the index buffer handles like your indices, and which is index, what it is really is, imagine like you have an array of like I don't know, vertices, for example. An index buffer basically is indexes into that array. That's essentially what it's for. Alright, moving on. Implemented a 2D texture already. That's why you can see the kind of channel, the logo on the screen. Now, the next texture object I need to implement is 2D texture arrays. Basically, think of them as like a 2D texture array, a 2D texture, but it has different layers that you can look at using the Z chord. They're very, very useful for like having a bunch of textures in one, and you just want to bind just that one kind of atlas of textures. I'm going to be using this with tile mapping and object mapping. And this next one is uniform buffers. I'm going to need these because the project will require multiple programs, or I guess shaders, shader programs, and I need communication between all of them for like the projection matrix and the view matrix. So a uniform buffer is pretty much the standard for that type of like communication between those shader programs when it comes to like variables. So I'm gonna have to add another object to the shader pipeline again, which will be a uniform binding point, I believe is what they're called. I have to look it up later. And frame buffers, because I want to make sure the screen can scale, and that's going to require basically an image to texture. So I had to have a frame buffer to do that, or an off-screen frame buffer technically. Okay, let's get to beyond GLW, talk about what the rest of the renderer is going to do. Those components, that's not the renderer. That's these components that I need to wrap up in OpenGL to make it more kind of the way I think how a renderer should work. I'll show you with some code. Let's see here. Sorry, I'm getting cold right now. go look at where is GLW. Let's click right here. Alright, here is like the object descriptions I'm doing currently. Oh my god. I hate this weather. As you can see, this basically wraps up just everything. I'm probably gonna have it where I can have my own enum, so I can just kind of separate OpenGL out of the mix. Because I want to make this kind of wrapper agnostic to any graphics API, so I can use like directory down the line. I'm gonna have to note that for later on. Have your shader, vertex array, and the other ones down here. The actual renderer is a bit different. It's basically this kind of thing. This thing, as you can see, it's way more simple than those objects, and that's how it should be. I'm gonna put down a comment here quick. The reason why I want to remove this function. And I'm going to have to change it to view. Alright. Now let's keep going. Basically, I'm using GLW to build this renderer and to make things simple. As you can see right here, excuse me, if I change the resolution of the screen, this is going to have to change internally because it's going to be recorded to a frame buffer when you're using this API, and I want to keep it at 640 by 480 internally for like a standard 3:4 ratio. 3:4 ratio? I don't know. Yeah, for a 4:3 ratio, I probably should put that in. Or if I detect a 16 by 9 ratio, then I want to change it to the 361 for like a widescreen kind of widescreen aspect ratio, and it has to do it dynamically for when you choose a resolution. And let's get back to the issue at hand. So yeah, that's pretty much kind of the introduction to the renderer. Sorry, I have not been feeling good today. Oh yeah, I forgot. I'm also going to be adding a font renderer too, because I need to display text data to the screen as well. So yeah, that's one update I need to add. So, yep, I hope y'all take care and see you in the next video.